In this video, we're going to explore some transformations using Geogebra. So you need to go to geogebra.org. That should take you to this page. And then you hit calculators, and we want to go to geometry. You might want to be signed in. I'm signed in over here so you can save your work. Okay, so we're going to start with the first one that we did by hand the other day, which is reflecting a triangle over two intersecting lines. So the first thing we want to do is draw our intersecting lines, and we want them to be at a 25-degree angle. So I'm going to click line and do 2 points, and then I'll make A my center here. Okay, so go back over here and click that to choose something else. Now what we want to do is we want to measure this angle in here and make sure it's at 25 degrees. So I'm going to go to my measure angle, pick 3 points. There we go. Click that again. Move this so I can kind of see. Okay, so that's at 30. So I'm going to take this and I'm going to move this into 25. Perfect. Now I think we called this center O right here. We can click on that and rename that O. There we go. Capital O. Let's do that. Okay, I'm having troubles here. Let's try this again. Okay. Capital O. Oh, now what did I do? You'd think this was the hardest part of what we're doing here, huh? All right, there we go. So, and we were going to use C and B for some other things. So let's change these to other stuff. Maybe let's call this point L, because remember we were going to talk about line L versus line M. I'm not sure we can name our lines. We could try it, but maybe if we just name these points little l and little m, then we can use those as references for this is going to be line L and this is going to be line M. Well, it might let me name the line. Let's try that. Is it naming it? I don't see it anywhere here. Yeah, I don't know. Okay, so let's put our triangle in there now. So we're going to choose a polygon, and I'm going to pick a triangle, and like we talked about yesterday, I want to pick a triangle that's not equilateral. And it's labeling it ABC, which is perfect because that's what I want. Okay, so remember yesterday the first thing we did, we used the mirror to reflect this over line L. Now we could move this wherever we want, but you know, we can set it right there is fine. If you want to move it around before you reflect it, that's fine. And actually, you're going to be able to move it around after you reflect it, which is really cool. So let's go down and find transform. Okay, so notice here, transformations. We see some things we've been working on. Translate by a vector, rotate around a point, reflect over a line. These are 3 of the isometries that we've learned, 3 out of the 4. The 4th one being a glide reflection, which a glide reflection can be obtained by a translation followed by a reflection or vice versa. So we can use a combination of translation and reflection to accomplish a glide. But we're not doing a glide, we're just doing a reflection here, right? So I'm going to choose my triangle, and then I'm going to come here, I'm going to go reflect about a line. It says select object to reflect, and then the line of reflection. So I'm going to select the object to reflect, and then the line. Look at that. And it even labeled it A double prime, B double prime, C double prime for me. Wonderful. Okay, so now I want to reflect this triangle over line M. So I'm going to hit reflect again. I'm going to say reflect this triangle over line M. Beautiful. Now notice because line M went through A prime, B prime, C prime, that A prime, B prime, C prime overlapped with A double prime. And it did all the labeling for us. Pretty cool. Okay, now watch this. I went and chose my, just my pointer again. I'm going to grab this triangle. You ready? This is going to be amazing. Ooh, look at that. See, it's still, if I move it over here, that's the reflection over L, reflection over M to the double prime. And I could, I can even change the triangle, huh? And it still maintains that reflection. Well, that wasn't what I was trying to do, but that's kind of cool too. So mess around with this a little bit. That's kind of neat. Pretty cool. Okay, so after you're messing around with that, make that stagnant, just pick something. Now remember, the next thing we did was we measured the angle of the rotation itself. So the transformation that we're looking at is triangle ABC over to triangle A prime, A double prime, B double prime, C double prime. This one right here, the prime one, is sort of an intermediate step of the translation. So I'm going to click on this and I'm going to color this a different color, maybe a lighter color like orange, and maybe I'll even, can I make it like less transparent, maybe like that. And then this one, maybe I'll make that even a little bit darker. How do I do that? Yeah, here, I'm going to choose that to be a little bit darker like that. You mess around with what you like, but what I'm trying to do here is really highlight the fact that the transformation is from this blue triangle to this blue triangle. That's the transformation I'm looking at. That's the rotation I'm measuring, not anything to do with this orange one. Okay, so now we wanted to measure angle A double prime. So I am going to draw, I can draw two rays. I may be able to draw an angle, and then I'll measure it. We know an angle is two rays or two line segments. We could either do segment or ray. Oh, let's just do segment to keep it from going off the page. So I'm going to go segment A to O, and then segment O to A double prime. I'm going to pick my pointer here. I may even change the color of this again to highlight it. Maybe we'll change it to red. Change this to red. Okay, so the angle I'm measuring is the angle between these two red lines here. So now I'm going to go to measure angle A double prime. Choose my pointer. I got to go down here and grab this angle. There it is right there. There's the 50. Maybe I'll move this 25. Maybe I'll even change the color of this 50 to red. That's nice. So that really highlights the fact that this 50 corresponds to this red angle right here, where the 25, remember, is the angle between the two lines. So again, I can grab this triangle and move it around. Oh man, that's cool. Now the 50's not, see that red angle is still 50 degrees. This little indicator's not moving with me, but isn't that neat? That's pretty neat. Pretty dynamic. Now you could do the same thing with B double prime or C double prime. Maybe do one more of those. It can certainly get a little messy if we do too much. But let's do CO and then OC double prime. Let's make those a different color so it's not messy. How about green? We'll make this one green. That's lovely. And then we're going to measure the angle from C to O to C double prime. Choose my pointer, grab that. It's still 50. Maybe I'll make that green to, again, highlight the fact that's the measure of the green angle. Pretty cool. All right. No matter where I start here, those angles are still 50. Okay, now, we had this hypothesis that the angle of rotation was twice the angle between the lines. Certainly looks to be true for 25 degrees. We could test that hypothesis now by actually changing the angle between the lines. So if I pick this point L right here, I'm going to pick this point L and I'm going to drag it and change the angle between the lines to something bigger than 25. And we can watch how that affects this angle of rotation. You ready? Here we go. Ooh, that's exciting. Let's just move it to 60 degrees and take a look at what we've got. Okay, so now notice the construction still stands how we built it. This initial triangle ABC is reflected over L over here. And then this orange triangle is reflected over M down here. And we have the angle of rotation is twice as much as the angle between the lines, 60.7 in this case. One more thing I want to highlight here about the reflections themselves. We've talked about how if I create a segment with the reflection, that segment is bisected by the reflecting line. So let's put those segments in there. So I'm going to do segment A. Nope, cancel. I don't want segment with a given length, just a segment. A to A double prime, or excuse me, A prime, and then A prime to A double prime. Okay, and I'm going to make those a different color because it's getting messy. Let's see, what colors do we have left? Orange. Let's do orange. And then this line, orange. Oh, we can add a color? Oh, look at that. We have a whole palette over there. Okay, I don't want to get distracted. This is where it gets in the weeds, right? Let's just choose orange. So, okay, I want you to look here. Let's just look up here because this one's easy to see. Notice this is the perpendicular bisector. And then this is the perpendicular bisector here. M is the perpendicular bisector of A prime, A double prime. Let's actually measure that. Okay, so I'm going to put a point. I'm going to put a point at this intersection right here. That's the intersection of A prime, A double prime, and line M. And then I am going to move these angles out of the way. There we go. I'm going to show that M is the perpendicular bisector of A prime, A double prime. So to do that, I first need to show that these are perpendicular. So I'm going to measure that angle. Measure angle M, D, and then A double prime. 90 degrees. Awesome. Okay, how do I show it's a bisector? To show it's a bisector, I need to measure the length of A prime to D and then D to A double prime. Measure, where's measure length? Angle, angle, distance or length. There we go. A prime to D and D to A double prime. Look, they're both 7.3. It's bisecting. And we can go back, we can pick this move thing, we can move this whole business around. Wow. Move it around, stop at it and stare at it for a minute. You can even take one of the points of your triangle and like move it out of the way to see things better if you want. And you could do this angle perpendicular bisector bit between A and A prime if you want, measuring the angle and the distances like we did from A double prime to A prime as well. Okay, so hopefully this convinces you of a couple things. First of all, that the angle of rotation is indeed twice the angle between the lines, and that when you're dealing with a reflection, that if you create a segment between the pre-image and the image, that the reflecting line is perpendicular to and will bisect the segment connecting the pre-image and the image. All right, so before we do anything else, let's save this thing. Let's see, how do we save? That's okay, so we hit this button up here. Hit save. Let's call this rotation over L, then M. Save. Okay. Now, if you wanted to copy this and paste it into your submission for the lesson today, that will be your credit for this particular activity. Okay. All right, so we could do the same thing reflecting over the lines in the reverse order. I'm not going to have you build that in Geogebra right now, but we are going to do something over parallel lines. So I'm going to help you set up the parallel lines one and then have you kind of finish that on your own. So I always get a little bit scared when I start over that I'm going to lose something. So make sure that you save this. Either save it online. If you logged in, you can actually save it to your computer as a file. I usually save my stuff. Okay, it makes me nervous. And then I'm going to go clear all, which makes me so nervous. But if I go back here and click this and then go open, hopefully it's going to be, there it is right there. Okay, it saved it for me. Whew. All right, so the next one we're going to do is the parallel lines. How do I make this go away? I want that to go away. Oh, there's a settings button just outside. You can't see it, but I think if you click that settings button, it might go away. Oh, there's a little X button out here. There we go. Okay. So now we need parallel lines. So we're going to construct parallel lines. If I click on this, it says select parallel line and a point. So I have to start with a line and a point, and then I can construct the parallel lines. So I'm going to go up here. I'm going to make a line. Very good. And then I'm going to pick a point not on the line, anywhere you want. And then I can do my parallel line, and I click the line and the point, and it creates those parallel lines. Now from here you could drag C closer. Notice it keeps the lines parallel because that's how you built it. You could move any of these points. Now again, we were going to label our triangle ABC, right? So maybe we rename these points. Again, we could call this little L. Oh, I didn't want to do that. Edit, undo. We could call this little L to signify that that's line L. And we could call this little M to signify line M. And then I don't care what we call this. Let's call it O. All right, so we're going to build our triangle again, just like we did before. Oh, no, we're doing a rectangle or a quadrilateral this time, right? So we're going to, oh, I don't want a regular polygon, just a polygon. 1, 2, 3, 4. Close it. You can go back and reshape it if you want into some other kind of shape. And then you're going to do the reflecting over the lines again. And then you're going to measure how far that it moved and how far it translated. So I want you to do the reflections, okay? I know in the transformations down here you can do rotations and translations, but I don't want you to use these. I want you to do the 2 reflections just like we did by hand and just like we did in the last activity. Okay, we can go back and mess around with these later, but we're doing it by doing a composite or a series of 2 reflections. And then you're going to measure how far that it translated, and you're going to measure the distance between the parallel lines. You can do that here. We can select these 2 lines. Does it measure the distance? Oh, no. To measure the distance between the lines, we actually have to make a perpendicular to measure the distance between the lines. So let me show you how to do that. We can do perpendicular line. So we can do a line perpendicular to this. And then we can call this point right here E. And then actually we could measure the distance. Measure distance between here and here, and there's the distance between our lines. I kind of don't like having this perpendicular in here. It's like kind of distracting to make it a little less conspicuous. Maybe we could like color it white. We could color that line white, and then it sort of goes away, but we still have this distance between these lines here. Right, but now it's not in the way. That's kind of interesting. Okay, so I want you to complete this activity in Geogebra, activity from the worksheet that you did yesterday. And you will save that and submit that as well.